All right, so chapter 2, folks. We made it through chapter 1, the review stuff. Now we have to actually start getting into dealing with fractions. We like them, or at least we accept that they are necessary, and we're learning to like them. One of the two. All right. So, oops, I'm blue. Hang on. What does a fraction look like, folks?
Number over another number.
A number over another number. Exactly. All right. So, A over B. And what do we call the number on top? And the number on bottom? Okay, good. Numerator, denominator. And for those of you that don't know, I'm an Indiana boy, so the way my 3rd grade teacher taught me how to remember which one was numerator and which one was denominator, she said Notre Dame, right? Because Indiana, the school, is Notre Dame, which I was never a Notre Dame fan, so yeah. But anyways, what she used to do as my 3rd grade teacher was that whenever we worked on fractions, she would get out a tape recording of the fight song for Notre Dame, and she would start playing it. And so as we're dealing with fractions, folks, if you every now and then start seeing me march a little bit, that's because anytime I talk about fractions, I can't get that stupid song out of the back of my head. Okay, so it may look a little weird, but just bear with me, all right? So, numerator and denominator. All right. Now, what's one condition I have to say about this numerator and denominator, though? What can't happen in a fraction? No, they can be the same two numbers. It's actually okay. True. It would be 1, which is just a weird way of writing it, but it's okay. But what's actually bad? No, you can have improper fractions. That's okay. But what can't happen on the bottom? You're on the right track. 0, right. That's the one condition that can't happen in a fraction. The denominator can never be 0, okay? And the reason it can't be 0, folks, is that, remember, a fraction bar is really a division symbol, right? And so, can we ever divide by 0? If you ever try it on your calculator, it will always barf at you and say, unacceptable, okay? So, just realize that that's the one condition we have with fractions, okay? Denominator cannot be 0. Now, we have 3 types of fractions that you will have to be able to deal with. The first is a proper fraction. What does it mean for a fraction to be proper? It does not mean that it wears a suit and a tie to dinner. That's not how it works. Yes. The numerator is less than the denominator. And it does need to be strictly less than. Okay? None of this equal stuff, strictly less than. Alright? So, examples of proper fractions, you know, sort of the classic would be 1/2. That's sort of the simple one. All right, it can be lots of other things, right? It can be 3/5. Please note that there are other types of proper fractions that you look at going, hey, that's weird, but it's okay. It's not wrong. It's just weird, right? It's perfectly okay. It's even a proper fraction, right? It's just another way of writing 0 as a fraction. It's okay to have a 0 in the numerator, not the denominator. All right? And of course, you can have weird ones like 313 over 4,122, whatever. And you can have proper fractions like 2/4. But as soon as you see the fraction 2/4, your skin should crawl a little bit, right? Because what do you really want to do with that 2/4? Yeah, we want to reduce it. We'll get to there. Bear with me for now. But realize that non-reduced fractions are still proper, they're just not reduced. Okay? So, proper fractions. So if you can have a proper fraction, what else can you have?
Improper.
Improper, right? The opposite of proper is improper. And it is the opposite of proper. So what is the opposite of less than?
Greater than. Greater than.
Keep going. You're missing a piece.
Or equal to.
Yes. Don't forget the or equal to. All right. So here, the numerator
Some kind of far away from the height.
is greater than or equal to the denominator. Monroe, I have your microphone turned up pretty high, so you guys don't need to talk too loud, just so you know. All right. So, greater than or equal to, and again, that is also the opposite of less than. Right? That's one of those sort of tricky things that you don't think about, but it's there, right? The opposite of less than is not greater than, it's greater than or equal built into it, all right? And examples are, any number where the numerator is greater than or equal to the denominator is perfectly okay. You can have stuff like 7/3, or you can have, 2/1. There's nothing wrong with these sorts of things. And again, folks, there's nothing wrong with an improper fraction. All right? And in fact, there are times where I will tell you I would prefer an improper fraction. All right? Now, some other improper fractions that you can have, obviously, I said that they could be equal to, so the numbers can be the same. It's okay. Nothing wrong with it. It's just weird. What is this number, folks? 1, right? I mean, it's just a way of writing 1 that makes it easier to potentially deal with. And we'll get there when we get to problems that are like that. And you can have annoying improper fractions like 422/13. And please note that they can be negative. Right? Note when you write negative fractions, you tend to write the negative with the numerator. That's the accepted way of writing it. It's not incorrect to write the negative in the denominator, but if you ever do that, everyone will look at you and think that you're weird. Okay? It's actually considered bad form to write the negative in the denominator. It's okay in a math class. Everywhere else, it's bad. Okay? And in fact, most calculators, if you try to enter in a negative number in the denominator, it'll actually barf at you. It'll actually say that that's not a proper fraction. Okay? Again, we'll get to there when we get to there, but realize that technically when you're dealing with negative fractions, you should really put the negative in the numerator. Okay? So, when you are working with these improper fractions, like 3/2, what do you really want to write 3/2 as? You want to write it as 1 1/2. What kind of a fraction is that called? Mixed, yes. You can kind of call it either one. You can call it a mixed number or a mixed fraction. Either one. 6 of one, 1/2 of the other. And the key to dealing with mixed fractions, folks, I should be careful. This is an integer with a proper fraction. So when a number is mixed, you will have potentially a whole number and a proper fraction to go with it. Please note that when you write a mixed number, the fractional piece must be proper. If you do not write it as a proper fraction, it is wrong. It doesn't make sense. Okay, folks? There will be instances where it will look like we should potentially write the fraction piece as an improper fraction. You have to fix it so that it looks correct. Okay? So, the classic example, 1 1/2 whatever, 2 3/7. And it can be an annoying mixed number as well. Negative 113 and 2/17, what have you. Please note, a number by itself without a fractional piece is technically considered a mixed number. Okay? So if I ask you to write an answer as a mixed number and you just have to write a whole number by itself, that's fine. There's nothing wrong with that. Okay? Now, what would I write next to it if I wanted to have a fraction in here and have it be, in theory, okay? Well, if I put 1 over 1, then it would be an improper fraction next to it. That's bad. But you're on the right track. Not 1 over 1, but 0 over 1, right? So, in theory, you could write it like that. But as soon as you see that, what do you think? Yeah, you're weird. That's absolutely right. Okay? It's really weird to write 5 as 5 and 0 ones. It's not wrong, though. It's actually okay. If you wrote it, I wouldn't mark you wrong. I would just say, you're weird like me. And we would move on. Okay? But normally you just write it as 5 and we're all good to go. Okay? So, just to be safe, and because we'll run into these sorts of things, these are bad examples of mixed numbers. Exactly. The reason this one is bad is because the fractional piece is improper. If you gave me this as an answer, I would just mark it wrong and say, tough luck. Okay? Because this has to be written as a number and a proper fraction, not a number with an improper fraction. In addition, this number is also bad. Yeah, you cannot have a negative proper fraction with your mixed number, okay? If you wind up with something like this, you also need to fix your fraction or fix your mixed number so that it looks correct. We'll get to examples like this and handle it, but just realize that if you write this, you're wrong. Sorry. Okay? So the proper fraction, the fractional piece, not only does it have to be proper, it also has to be positive. Note, if you have a negative mixed number, note how it looks. The negative sign goes with the whole number, not with the fraction. Okay? And please note that 5 and negative 1/3 is not the same as negative 5 and 1/3. Those are two totally different concepts. Okay? And we'll get to there in a little bit. Alright, so, not bad? Now, as you guys said, improper and mixed, we can go back and forth. So, which way do you want to go first? Any preference? No? Okay, I'll pick. So, let's do improper to mixed. For every improper fraction, folks, there's a mixed fraction that is a representation of that same number, and vice versa, right? So, how do you convert that improper fraction into a mixed fraction? Divide. Okay, so how do we divide? Yeah, 14 divided by 3. How would you do it? How many times does 3 go into 14? In other words, folks, go old school. Note that the first test in this class, half of it is no calculator. You need to be able to do this by hand. Okay, folks? The only test is the first one that you will have to deal with any portion of non-calculator, but the first half. And these are the types of questions I'll ask. Convert this to, from one to the other. And they should be numbers that you can handle. So, how many times does 3 go into 14? 4 times. What's 4 times 3? So subtract. Your remainder is 2. How do you use those numbers to build your improper fraction? Yeah. Whatever number of times this number can go into the numerator, that's your whole number. The remainder is always your denominator. Your numerator, and your denominator always stays the same. Okay? Not bad? Okay, so just to be safe, because I always get nervous, because I know long division is kind of old schooly. So what if I gave you, let's say, let's go with, you get something that's at least a little bit of work. All right, so let's go with 283. Let's say, let's go with 14ths, not 13ths. 14ths. So, if you wanted to convert that into a mixed fraction, what do you do? Same thing. It's not like it's any different. Okay, it's just now you have to remember, how does this work again? Do you guys know off the top of your head how many times 14 goes into the number 283?
No.
You might be able to do it, but the way that we have been taught prior to this probably is we look at 14 and say, hey, can it go into the number 28? Yes, how many times does 14 go into the number 28?
2.
Twice. Please note that you put the 2 over the 8 in 28 so that you know what place it belongs in. And then you sort of play the same game. What's 2 times 14? What's 28 minus 28? You always get one number free coming down 3. How many times does 14 go into 3, folks? 0. Note that you need the 0 in here. Don't lose the 0, right? So every now and then I'll get someone who will tell me that this is 2 3/14. It's like, what? Really? Okay, don't do that, right? There's your remainder. Use those numbers to again build your mixed fraction. So whatever is up here becomes your whole number. Whatever is your remainder becomes your numerator. Always keep the denominator the same. Okay, so long division. And I'm not a big jerk, folks. I'm not going to put like a 6-digit number and a 4-digit number down here. But I could give you something like this, right? 3 over 2. That's as far as I would go on a no calculator test. So, but you should be able to do that, though. Okay, just be ready. Okay.
Yeah.
That was a good one.
I'm glad you changed it to 14 and not 13.
Yeah, that 13 sucks.
Yeah.
Okay, but
14 was easy.
not bad though. Okay, so now let's go the other way. Let's suppose that I ask you to convert from mixed to improper. So let's suppose I gave you 3 2/5, and I said, hey, I want you to write that as an improper fraction. Well, what did we do to go the other direction? We divided, so now we're going to go the opposite direction. What's the opposite of division? Multiplication. All right, so what do we do? 5 times 3 plus 2. So it's the integer times the denominator plus the numerator. And just like before, always keep the denominator the same. So using that little algorithm, you guys will tell me, great, this is 5 times 3 plus 2 all over 5. And what is 5 times 3 plus 2? 17. Yay. 17/5. So be able to go back and forth, folks. That's a classic couple of the first two or three questions on the first test. Non-calculator piece. Okay? Be able to go back and forth. All right. Just be a little bit cautious. I like to show this example because it kind of points something out about formulas that we work with, right? So convert this number, negative 4 1/3, into an improper fraction, all right? Let's use the formula I gave you, right? What's my integer? Negative 4. I'm going to multiply by 3 plus 1, and then keep the denominator the same. Now, be careful. What's negative 4 times 3? Negative 12, right? Remember, we played around with negative numbers a little bit. What's negative 12 plus 1? And what are you guys doing right now? What happened? How many times does 3 go into 11, folks? 3. How come these two aren't the same? Yeah, that was our problem. The minus sign is not a part of the problem itself, okay? Does this formula up here tell you that, though? No. And this is where you have to be a little bit cautious. I actually had a student once who did this exact same thing on a test. And I had to mark them wrong, but at the same time I was like, oh, you followed the formula, right? I mean, exactly. But you just have to realize that for negatives, that the negative sign has to be outside the parentheses of the entire operation, okay? If it's negative, you need to have parentheses here. And technically, what's 12 plus 1? 13. Make that a negative. That's the correct answer, okay? So this is one of those things where the formula that you were given is great, but it's only working for positive numbers. And we can obviously have some numbers that are negative. You've got to be cautious, okay? And so I like to point those sorts of things out so that you think about them before you come up with these sorts of formulas to say, hey, this only works when it's positive. How would I rewrite it slightly such that it works when it's negative? Okay, so for negatives, folks, please realize the negative sign is there, but it's what you deal with absolutely at the end. Okay? All right, so make sure that you can deal with that as well. So, not too bad? All right, so we can go back and forth. So, one of the things that you will always do in this class, folks, is reduce fractions. Okay? Just do it. Even if the book tells you not to, do it anyways. One of the few times I will tell you to ignore directions is when it says don't simplify the fraction, screw that, do it anyways. I won't mark you wrong, but alright, anyways, you should be able to reduce fractions. So you guys know that that's true, right? My question to you is, why? Yeah. But why? Why is it okay to do that? Why? Why does the same number make a difference? You're on the right track. Not quite. You can't multiply it by itself, right? So if I multiply
number into them, or divide the same number.
exactly. Why is that okay? Why is it okay to divide the same number in the top as it is in the bottom, and the number doesn't change? It stays equal. Why is that? I mean, you know it's true, right? I mean, we all know it's true. But the question is, why? It's so obvious, right? I mean, it's like, well, draw pi and cut it into 4 parts. And show them that the 2 parts in the top are the same as if you just cut it into 1 part, and the 2 parts, right? But how would you explain it mathematically? So people would say, oh yeah, that works. So why is it important that the number in the top and the bottom are the same? What happens when the numerator and the denominator of a fraction are the same?
Makes a whole number?
Exactly. What kind of a whole number? I mean, if you have like 3 over 3, what is that really?
So it equals 1 anyways.
It equals 1. So when you guys divide by 1, what happens? It's the same number, right? What's 4 divided by 1? 4. What's 2 divided by 1? 2. What's 8 divided by 1? 8. When you divide by 1, the number doesn't change. So if we have 2 over 4, and we're going to write divided by 1, but I'm going to write 1 cleverly. And now what's 2 divided by 2? 1. And what's 4 divided by 2? 2. So the key here, folks, is that when you're reducing fractions, what you can tell people is that you're not really reducing anything. All you're really doing is dividing by 1. Which is kind of cool, because that tells people you're not really changing the number. Because when you divide by 1, nothing changes. Okay? So, this is the sort of thing that even a 5th grader will understand. Because at 5th grade, you know, when you divide by 1, nothing changes. And you're just going to write it cleverly. That's all. And this is why I like to tell people that these improper fractions, like 2 over 2, are really awesome fractions, even though we never almost ever see them. We use them constantly, we just don't really talk about it too much when it comes to reducing fractions. Okay, so, anyways. There is a great word for the English language, folks. Divisibility. Divisibility. 6-syllable word. If you can use a 6-syllable word in a sentence correctly, you are a nerd. So, if you ever get a chance, when you go to a job interview somewhere, talk about divisibility, because it just sounds like you're a dork. Which, I know that that's not necessarily a good thing, but in a business interview, actually, it is, right? So what does it mean to be divisible, or what is divisibility? Yeah, it's just stuff that divides evenly, which is, I mean, kind of an obvious thing. But again, if you can use the word to explain it, oh, it's nice. All right. So folks, when is a number divisible by 2? When it's even, yes, exactly. Or what I'm going to say is the last digit is even. Right? That was pretty straightforward. I'd like to think that you guys all know that. I'm going to put a star next to that rule. You should know that rule and be able to apply it without a calculator. In other words, you should be able to take numbers and divide them in half. Okay? Now, you should also know this rule. When is a number divisible by 3? Does anybody remember what the rule is? 12. Awesome. There you go. Add up digits, and sum is divisible by 3. then the entire number is divisible by 3. So in other words, if I put the number up here, 432, is that number divisible by 3? Why? Because what's 4 plus 3 plus 2? 7, 9. Is 9 divisible by 3? That's a nice smaller number. This entire number is divisible by 3. If you divide 3 into this, it will come out even. Okay? So that is a very handy rule for you to be able to check to see if a fraction can be reduced. Okay? All right, now, again, please memorize this one if you have not done so in your prior life. Okay? Because again, I'm going to ask you to do it on the test, so you need to know how to. All right? Please note that I'm not starring number 4. You don't need to know this one. But I want to write it down because it points something out. Okay? The way to determine if a number is divisible by 4 is if the last 2 digits are divisible by 4. Just the last 2 digits. So no matter how many digits you have in your total number, if you just look at the last 2, you can tell whether if the entire number is divisible by 4. $23,124. Is that number divisible by 4? Yes. What are the last 2 digits? 24. Can 4 go into 24? Yes. Therefore, it's divisible by 4, which is kind of a nice little rule, right? And note how it compares to the rule of 2. For the rule of 2, how many digits do you look at? Just the last one. The rule of 4, which is 2 2's, how many digits do we look at the end of our number? Last 2. Oh, what are you starting to potentially notice? Pattern. And what is the one thing in business that every business gives a crap about right now all the time? Noticing patterns, right? If a business can figure out what sort of a pattern you have in your life, guess what they can do? They can send you advertisement, they can send you coupons to try and manipulate your behavior so that you will spend more money on their product. That is what business is paying for right now. This is why businesses are clamoring at people like me saying, hey, come look at my data. Find the patterns. And oh, by the way, here's 20 trillion records about my customers, right? Starbucks, folks. Do you know why they want you to have a Starbucks card? Well, that data is nice, right? If Starbucks grabs your Starbucks card and checks out how many times you buy a Starbucks every month, and they notice that you go to Starbucks twice a month, beginning of the month, in the middle of the month, because that's when you have money, right? And you're like, that's when I can go ahead and get it. So what does Starbucks want you to do? How many times does Starbucks want you to go to their store? They'd love you to go 10 times a day, but, you know, more than twice, right? So if they know you go, like, from the 1st to the 5th, and then, like, the 15th to the 20th, what might they do around the 8th or 9th of every month? Yeah, they'll send you a little coupon that says 50% off on your Starbucks if you buy between the 8th and the 10th. And when you buy between the 25th and the 27th. And you're like, ooh, Starbucks, half off. Yeah, I can go. I got the money. And so you start going in the, the 2nd and the 4th week. And they do this 2 or 3 times or 4 or 5 times. Enough times that it becomes a pattern for you. Guess what? That 50% coupon, all of a sudden it starts becoming like, say, a 25% coupon. And then a year later, when you've been going every week for a year, all of a sudden that coupon will stop showing up. But folks, you've created a pattern for yourself. You go every week. Do you think Starbucks wants that to happen? Do you think every store that you shop at wants that to happen? Duh. Okay? This is why patterns are such a big deal. And this is why I will continually, throughout this class, try and get you to recognize and look for patterns. Okay? Because it's what's happening in the business world right now that's making money. And so you need to start doing it. Okay? So, anyways, I mildly digress. Okay, so technically you don't need to know this, folks, but it'd be cool. I would like to think, folks, that you know this rule. I don't need to worry about it. When is a number divisible by 5? Okay, good. Okay, so these three are the three that I want you to know. Numbers that are divisible by 2, numbers that are divisible by 3, and numbers that are divisible by 5. Okay, that's it. Please memorize those 3 rules, and 2 of the 3 you should really already know. Okay? So, 2 and 4. Be a little careful, folks. What's the next number in this pattern? Remember that divisibility is multiplication and division, not addition and subtraction. So, what's the next number in this sequence? 8. Because that's 3 2's multiplied together. What's the rule of 8? I don't even want to write it down. What is it, guys?
The last 3, probably.
Uh-huh. The last 3 digits. And what do the last 3 digits have to be? There you go. And you could take this to another level if you wanted to, and another level, etc. All right? And again, these are patterns. Sorts of things that you want to be able to see, or you want to be able to create and follow as needed. Right? So, I don't want to go down the rabbit hole too far, but that's the good stuff, folks. All right, so really quickly. Let's simplify 234, 430 seconds. This is a question that I ask on the non-calculator portion of the test quite regularly. In fact, last semester I think this even was the fraction that I asked. Maybe it was last year. It was within the last 2 years. Let's leave it at that. So, again, no calculator. How would you go about attacking this problem? What would you do first? Note, remember the 3 things that I care about, right? 2's, 3's, and 5's. Which of these is the easiest to deal with? 2's, right? Because it's just taking things in half. So start with 2's. Why are both of these divisible by 2? They're both even, okay? So, when you divide by 2 over 2, what do you wind up with? What's half of 234? If you didn't know it off the top of your head, how would you figure it out? Yeah, you would just go, oh, I remember this. 2 into 2, 3, 4, right? 2 goes into 2 once. Bring down your 3. 2 goes into 3 once. 2 goes into 14, 7. Perfectly okay if you do this on the test, folks, when you don't have the calculator available to you. Going old school is okay. I'm old, so I'm okay with old school. I'm not that old, but I'm not. All right, so what's half of 432? 216. Okay. Once you do 1, 2, folks, always do as many 2's as you possibly can. Okay? So, can we divide by 2's again? Well, the bottom's even. Can we divide by 2's? Yeah. You can't because the top isn't even anymore. Now, once you're done with the 2's, now go to your 3's. What's 1 plus 1 plus 7? 9. What's 2 plus 1 plus 6? 9. Both divisible by 3. If If you can't divide by 3 in your head, what are you going to do? Do long division. There's nothing wrong with sitting down and doing it long-wise, folks. I have no problem with that. 3 into 117. 3 goes into 11 3 times. 9. 3 into 27 9 times. Sweet. And that one I can do in my head is 72. And so we're done, right? 39 to 70 seconds. Just like you should do the 2's twice, you should do the 3's twice, folks. What's 3 plus 9? 12. Divisible by 3. 7 plus 2? 9. Divisible by 3. Keep going. How many times does 3 go into 39? Hopefully you guys can do that one in your head. 13. And 3 goes into 72. If you don't know that one off the top of your head, that's 24. 13 24ths. Okay? That is not an uncommon question to find on the first test on the no calculator side of things. Okay? Now, when you guys go to do your homework and you're asked to reduce fractions or do whatever stuff that you need to do, you can, if you wish, on the homework, use your calculator. Perfectly fine. Just remember that when the first test rolls around, there's going to be half of it where you can't. So please practice a little bit without. By all means, use the calculator to check. Definitely, right? But first steps, do it by hand just to be sure. All right? So, not bad reducing? All right. All right, so, Alright, so to reduce, I don't think we need to be anymore. Alright, so let's then just slip into adding and subtracting fractions. Okay. So, first question. Okay, good. You do not just get to add the numbers going across, folks. That's just wrong. Okay? It doesn't work that way. This is false. In order to add fractions, you need a common denominator. And a lot of times I will pull out the pieces of pie that I have sitting in my desk, which I left in my office today, sorry. And remind you, right, that if you just could add the numerators and the denominators, think about this problem. What is 1/2 plus 1/2? If you just add it across the top and add it across the bottom. Yeah, this is going to be 2 over 4. And what's 2 over 4 really? 1/2. So you guys are telling me that 1/2 plus 1/2 equals 1/2? Yeah, no. Okay, so please remember that when you are adding and subtracting fractions, you must get a common denominator, right? Okay. Must get common denominator. Alright, so what would I do in order to add 1/3 and 2/5? So what do I need? What is my common denominator? 15. That also happens to be the least common denominator. Folks, I do not care about the least common denominator. There are some problems in the text that talk about finding least common denominators, and you can read that stuff if you wish. But please note that I will never ask you on a test what's the least common denominator. Okay? As long as you find a common denominator and then reduce at the end, I am happy. Okay? So again, there's a good page in the text that talks about how to find least common denominator, and I would love it if you guys played around with it a little bit, but realize I don't care, okay? Because you don't need it, right? That's for grade school. This is college. Give me right answers, I'm okay. All right. Now, what do I do to get this particular fraction to have a common denominator? Multiply 1/3 by 5?
No, 5 is 1 equals 15, and 5 is 1 equals 15.
Okay, exactly. So you want to get the common denominator to be 15, but I'm not going to multiply by 5. Technically, what am I multiplying by? 5 over 5, which is really 1, right? That's why you're not changing anything. Because what you're doing is multiplying these things by 1, written cleverly, right? And so, yes, you're going to have a different looking number, but it is the same because you just multiplied by 1. All right? And likewise on the other fraction, multiply by the 3 over 3 so that you get the 15 in the bottom for both of those. All right? So, again, please make sure that you get the common denominator so that you can just add. All right, so when you multiply, what do we wind up getting? 5/15, 6/15. And please, 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 pretty please, do not do what a student did to me a couple of years ago. They were very good. They found the common denominator, and then what they wrote down was this. Made me very sad. Because, of course, if you do it once, yeah, did it throughout the entire test, and it converted a paper that should have been probably an A into basically just barely being C. Okay, because obviously that's extremely wrong. When you add fractions, what do? Keep the denominator, just add the numerators, right? 11/15. Okay? So again, finding common denominators. Note that this is always a technique you can use when you're adding two fractions. Always. You can always, to get a common denominator, take the other fraction's denominator and multiply it by the earlier one. It always works. Okay? Now, it may not give you the least common denominator, but it will always give you a common denominator, and that's enough. Okay? So in other words, if I gave you, say, these two fractions to add together, 3/4 plus 1/6. Now, if you know what the least common denominator is, that's great. You can use it if you want. It's okay. But no, it's okay to say, hey, look, I can do the same thing I just did a second ago, right? What's the other fraction? It's 6's. Fine, I'll multiply by 6 over 6. This side I'm going to multiply by 4 over 4. (18 24ths) plus 4 24ths. What's 18 plus 4? And what can you guys do with 22 24ths? Simplify to 11 12ths. And note, guess what your real least common denominator was? 12. You could have multiplied this one by 3 over 3 and this one by 2 over 2, and if you saw that, you could get to 11 12ths sooner. Great. Awesome. More power to you. Please do it. If you don't see it, it's fine. Because you wound up at the same answer, right? It's okay. This is why I don't harp about least common denominators. As long as you are careful to reduce your fraction at the end, you're always fine. Okay? So just bear with me on that one, all right? Now, you can get nice examples. So let's suppose I asked you to add 3/5 plus 9/10. You could, in theory, do the exact same thing we just did a second ago, as I throw the pen around. But what do you notice about 5 and 10, folks? Yeah, 5 can go into 10. This is a real easy fraction to convert to a common denominator because 5 times 2 gets you to 10. And what's 6/10 plus 9/10? Okay, now here's where we start to run into terminology issues. All right? Because there are potentially 2 different things you need to do with this fraction. One is reduce, 2 is convert from improper to mixed. Please note that those 2 things are totally different. Okay? You always need to reduce a fraction, but the directions on this problem may say leave your answer as an improper fraction. If that's the case, folks, do not convert it to mixed, okay? So please, pretty please, read the directions and follow them. I've been saying this for 10 years, and invariably, at least 20% of you will not bother to read the directions and give me the answer the way you think it should be instead of the way the book tells you it should be. Okay? Just read directions. And this goes doubly on the test, folks. Okay? I am going to give you directions on how I want the answers to look. You need to give me the answer the correct way. Now, if I don't tell you which way I want it, if I don't say it needs to be mixed or improper, then either is okay. And I swear, folks, that I am okay with improper fractions. I really am. Now, you do have to reduce this, though. Okay? If you left this as the answer, I would still take points off. Okay? You need to be able to reduce this down to 3/2 because there's a 5 in both of those. That you do need to do. Okay? But at this stage, look for directions. Okay? And that becomes a bigger deal when we start talking about decimals, because decimals often the directions will tell you where to round the decimal. And again, follow the directions so that I don't have to, put a big huge stab mark in your homework paper as I go to grade it. Like, you know what I mean. Don't disappoint. Now, I am perfectly okay if you want to do both of them, and if the directions say pick one or the other and you circle the one, that's fine. I'm okay with that. All right? There's nothing wrong with that. But just again, make sure that you follow directions. All right, so not bad. I will now get down off of my follow directions horse and try not to beat on it again until next class. Okay, so what happens when your fractions are mixed fractions? You're asked to add them. There are kind of 2 roads that you can go through here, folks. It kind of depends on you as to which one you prefer. You can, if you want, just make both fractions improper, get a common denominator, add, and then convert as needed. Or you can add the whole numbers and then add the fractions. Either way. Okay? So either convert to improper, or add whole numbers, then add fractions. Either way. All right? And honestly, I think that you can pick and choose which of those you want to do depending on the situation, right? So this situation, it might be easier if we just added the whole numbers and added the fractions, right? Because converting everything to improper would take a lot of work when the numbers are not that painful, right? What is 4 plus 2? What is 1/3 plus 1/6? again, what's 2/6 plus 1/6? 6 and 3/6, and what will you tell me that is? 6 1/2. Okay, not bad. Again, I'm perfectly happy either way you go about doing things. If you want to just convert everything to an improper fraction because it makes everything safe and easy, I'm good. But that was equally as easy. Now, what I have to warn you about from using that technique, though, is this example, right? What is 4 and 4/5 plus 7 and 2/5? So note, I made it nice and easy. You already have a common denominator. I'm such a nice guy, right? But when you add these, what do you get, folks? You add the whole numbers. What's 4 and 7? What's the fractions? What's 4/5 plus 2/5? And what am I going to do if you leave the answer like that? Why am I marking it wrong? Yeah, because this can't be improper. So how do you fix it? All right, exactly. Convert to mixed. And add. So the way you fix a fraction when the fractional piece has an improper piece with it is you just go ahead and say, this is 11 plus 6/5 is the same as 1 and 1/5. What's 11 plus 1 and 1/5? 12 and 1/5. Okay, so there's where you have that situation where you might have an improper fraction on your fractional piece. Just don't stop. Okay? Alright. Not bad with adding? How do you subtract fractions? Same thing, but instead of adding, subtract. I'd like to think that's pretty straightforward, right? Remember that girl who did the adding of the numerators and the denominators? All of her subtractions fine. So she did 4 minus 2, but didn't do 5 minus 5 and write 0. And I was like, oh. I think I even tried it, because I noticed while she was taking the test. I was like, oh, no, you didn't do, no, what did you do here? Do that everywhere. Didn't work. Okay, so anyways, yes, when you subtract, you subtract. And again, if you don't have a common denominator, get a common denominator. Okay, so, if I said 2/3 minus 1/10, what are you going to do? What's my common denominator here, folks? 30, least common denominator. Note, if you don't want to write the multiplication down and you can do this in your head without screwing it up, I am okay with that. Okay, so if you know that this becomes 20 over 30 minus 3 over 30 without having to write out the multiplication, that's fine. You don't have to show me all of your work all the time. What I do like to tell students, though, is that when you show me the work, I can point out when you make a mistake a little bit more easily. Whereas if you don't, then it's harder. But kind of up to you to some degree. All right, so I don't need to do any more like that, right? Okay, thanks. All right, so what happens when you subtract mixed fractions? Again, you can go down both of those same rules, folks. You can either make these fractions improper and subtract, or if the numbers are nice, it is okay to subtract the whole numbers and then subtract the fractions, right? So this subtraction is nice. Because 4 minus 1, what's 3 minus 1? If your fraction is nice like that, folks, subtract the whole numbers and then subtract the fraction. Okay? And then if you need to, what do you have to do at the end? Please make sure you reduce at the end. Now, what do we do when it's not nice? Because you know that I'm going to force you to deal with examples like that, right? So what is 10 and 1/5 minus 4, and let me make you think a little bit about this. How about 2/3? All right, so since we are subtracting fractions, what do we need? Common denominator. What is my common denominator? 15. Okay, so what does 10 and 1/5 become? And note, folks, what I tend to tell students so that they don't have to waste a lot of space, all you have to do is write the number in a slightly different color over your fractions to remind you which ones to multiply by. And again, the reason why I recommend that is so that you don't multiply the wrong numbers, which happens way more than you think. Believe me, I've been grading tests for 10 years, and you don't know how many times this winds up being 5/15 and this winds up being 10/15 because you multiplied everything by 5 because your brain farted. Okay? It happens. But if you write it down, it's less likely. All right, now, minus 4 and 10/15. Now, what's wrong with this subtraction? Yeah, we can do 10 minus 4 and get 6, but what's 3 minus 10? Negative, right? So if you wrote this as 6 and negative 7/15, what am I going to do? I'm going to mark it wrong. Now, quick question. Can I just be done?
No.
Why doesn't that work? Can't you just move the negative out in front? Okay, good. Please don't do that. And again, the reason I say that is because I've seen lots of people just do it. All right, so how do we handle these negatives? Now, one way to fix it is to go improper. It is perfectly okay to make both of these numbers improper fractions and just subtract, right? How would you convert this to an improper fraction? What's 10 times 15? 150 plus 3. This is why sometimes going to improper is annoying, because the numbers can be really big. And in the homework, folks, the numbers are like 296 and 1/8.
Or 7,100 over 432.
There you go. 7,100 over 432. Because 4 times 15 is 60, plus 10 is 70. There's nothing wrong with doing that. It will always work. That's the joy of converting things to an improper fraction, is that you will never fail at it unless you screw up the multiplication, right? Punch the wrong numbers in the calculator. Because then what's 153 minus 70? And if I said the answer had to be a mixed fraction, what would it wind up being? How many times is 15 going to 83?
5, 8.
That always works, converting to an improper. Now, I heard somebody say that you can also borrow. That is a perfectly okay technique as well. I have no problems if you borrow when going about doing this. Or 10 and 3/15 minus 4 and 10/15. How do you borrow, folks?
You take 1 away from the 10.
So you take 1 away from the 10. Hang on.
So it's basically 15 over 15, so you just add 15 to the 3.
Okay, good. Note, when you take 1 away from 10, technically 1 is the same as 15 over 15, right? So you're going to add that 1, 15 over 15, to 3 over 15. What's 3 over 15 plus 15 over 15? 9 and 18 fifteenths. The standard mistake that I see students do is that they'll tell me when they borrow 1 from the 10, they'll say this is 9 and 13 fifteenths. Why do you think people choose 13? Because we're almost always borrowing 10, right? Remember when you did subtraction, 81 minus 37. I mean, what do? When you want to subtract these? What do you do with the 8? You make it a 7. What does the 1 become? 11, because you add 10, because this is the tens place. Note, this is not the same relationship, right? These are 1s. You took away 1, not 10. And so you need to add 1 to this. And so what it really does is you will always add the numerator to your denominator to get your improper piece that you're going to subtract. Okay? That always works. And nicely enough, what's 9 minus 4? And what's 18 minus 10? Five and 8 fifteenths, either way you did it. Alright? And technically there's one last way you could look at this and see the answer. What is 6 minus 7 fifteenths? But the idea is that what's 6 times 15? Technically it's 90, right? This is 90 over 15 minus 7 over 15. What's 90 minus 7? 83 over 15, which is going to be 5 and 8 fifteenths. Any of those three ways work, folks. Okay? It's cool that all of those are essentially getting you to the same result. All right? Just don't stop here. That's the only thing that makes me sad. Okay? All right, and again, whichever you prefer, borrowing or converting to improper, all good. Again, though, folks, my advice is convert to an improper first, because if it's nice, or get your common denominator first, if you can just subtract, just subtract. If the numbers are good, if you're not going to get a negative fraction, just do it. All right? That's nice. All right? All right, so that's subtracting. You buy it? Is it true? Yeah, it is. And this is what makes students crazy. Because when you multiply fractions, you do just multiply across. Okay? That only works with multiplication. Do not do that with addition. Okay? So, when you multiply, just multiply the numbers across. Note, when you multiply the numbers across, what's 2 times 7? What's 5 times 8? What are you going to do at the end? Reduce. What does this reduce to? If you have done this trick before in your past lifetime, you may continue to do so. If you have never done that before, please don't. Just multiply the damn numbers and then reduce, okay? That's perfectly fine. There's nothing wrong with it, all right? Note that there's a couple of questions in the book that tell you do the cancellation technique. Please don't if you don't want to. Just multiply the numbers and then reduce, okay? That's perfectly acceptable, all right? Alright, so. Not bad? Okay. So what happens if you have to multiply mixed numbers? What is 1 and 2/3 times, that's a 2, I swear, 2 and 1/5. When you are multiplying mixed fractions, folks, you must convert to an improper fraction. You have to. You cannot just multiply the whole numbers and multiply the fractions. That does not work. Your answer is just wrong, period. Okay? So please convert to improper and then multiply across. So tell me that this is going to be 5/3 times 11/5, and then multiply across. 55 over 15. And what are you going to do with 55 over 15? Reduce. Divide both the numerator and the denominator by 5. What does it turn into? 11/3. And again, then here you would go to the directions and say, should it be improper or mixed? Whichever one, answer accordingly. All right? Please be careful. This is a question that I ask on the test very often. And I get a lot of responses where students tell me it's 15 1/4. Why? You cannot just multiply the whole numbers and then say the fraction comes along for the ride. That does not work. Everything must be converted to an improper fraction. 5 is 5 over 1. 3 1/4 is 13/4. What's 5 times 13? 65/4. If I asked you that to convert that into a mixed number, what does it become? 4 goes into 65 once. Carry a 2, 25. 4 goes into 25 6 times with a remainder of 1. Note that the answer is 16 1/4. You can't just do the 5 times 3 and say you're done. Okay? Please don't do that. And this is very commonly a test question. Alright? And that's a non-subtle hint. Okay. Enough said. Are we good with multiplying? Last but not least. When you divide fractions, here's my phrase that I try to get students to remember. We never divide fractions. We just flip and multiply. We don't divide fractions, folks. If you are asked to do 1/2 divided by 2/3, you will convert the division into multiplication. Convert division into multiplication by multiplying, whoops, whoa. If that's totally gone, I'm going to be pissed. Yes.
What's there?
Leave
Okay. We lost some pieces. Okay. That's weird. Okay. Where was I at?
Convert division into multiplication by multiplying.
Multiply by the reciprocal. What does the reciprocal mean, folks? The inverse of your fraction, right? So what was I doing again? Divided by 2/3. Okay, so you convert the division into multiplication. Please note that what you are dividing into does not change. The first fraction stays the same. What you flip is what you are dividing by. Okay, so this flips. And once you convert it into multiplication, do the multiply rules. And that's all there is to it, right? So 1/2 divided by 2/3 winds up being 3/4. Not bad? And so if you have to divide mixed fractions, let's suppose that, hey, move up. There you go. Suppose I asked you to take 3 1/5 and divide by, let's see, 1 1/3. Exactly. Convert both of your mixed fractions to improper fractions and then apply the same division rules that we just did, right? So, convert to improper, then repeat as above. So you will tell me that this is 16/5 divided by 4/3. Once you get them improper, now do the flip and multiply trick. 16/5 times 3/4. And now that you've got them written as a nice straight improper times improper, just multiply across. And then just make sure once you are done, simplify, right? These are both even. Take half of them. If they're still both even, please keep going. And note, read the directions as to whether 12/5 is okay, or I want you to write it as 2 2/5. Either way. Okay? Not bad? Alright, now, please bear with me, because technically, I know we only have like about 2 or 3 minutes left, but this is what you guys really wanted to get to. If you've looked at the homework, folks, you have probably noticed that the bulk of the questions are word problems. And note that on my tests, folks, basically the entire test is word problems. Okay? Only the first test, the non-calculator portion of it, will have some pieces that are not word problems. But after the first test, it's all word problems all day, folks. That's all there is to it. Okay?
I did learn how to use the little
tables. Yes.
That made it easier.
We will learn to use tables. That will be part of our task, is how to attack word problems better. Okay? So what I want to do is to just do a couple of really quick word problems that I expect you guys are having issues with anyways. Alright? So, really quickly. Let's see. I want one that looks relatively nice. Okay, so I have 2 1/4 cups of sugar. I use 1/3 of my sugar. How much do I have left? So, based on this word problem, folks, what do we need to do in order to get our answer? Subtract. Now, the problem with this one is, can we just take 2 1/4 and subtract 1/3?
Nope, you gotta convert.
Why can't you just subtract those two? I mean, why
It
can't?
doesn't have a
Well, let's suppose that I just found a common denominator.
Because it's 2 3/12 minus 4 and 4/12, and you can take
Well, no,
4
no.
away from
You're already actually too far ahead. Okay? How much sugar am I using, folks? A third of what?
which is bigger than a 4.
Yeah, I'm using a third of the 2 1/4 cups. Am I using a third of a cup of sugar? No, I cannot just subtract 1/3 from 2 1/4. Because I didn't use 1/3 of a cup of sugar. I used 1/3 of the sugar. So here's one of the things that I want you guys to start getting used to. When you read these word problems with fractions, if you ever see a fraction followed by the word of, that means something. This means multiply in order to figure out how much sugar you used. Okay? Because you did not use 1/3 of a cup. Right? 1/3 of 2 1/4 cups is not going to be exactly 1/3 of a cup, right? 1/3 of a cup is 1/3 of 1 cup, not 1/3 of 2 1/4 cups. This is something that students have a hard time with. Because you know you need to subtract, but the problem with it is that you don't know what to subtract yet. Okay? So, how much sugar did I use, folks? A third of 1/3 times, how much sugar was there? 2 1/4. How do I multiply fractions? This is 1/3 times 9/4. 9/12. And nicely enough, folks, what's 9/12?
3/4.
That's how much sugar I used. 3/4 of a cup of sugar. Now, how much is going to be left? Now you subtract. 2 1/4 cups minus 3/4 cups. And note, this is what I try to point out to students, is that the label on the two things that you're subtracting is the same. Alright? When you tried to subtract 1/3, it wasn't 1/3 of a cup. It was 1/3 of the sugar. You needed to figure out how many cups. And that's why I like to have students label things carefully. Okay? So please do not fall into this trap. There's at least one problem on the homework. I'm pretty sure there's two where you're going to have to do a similar type of thing. Right? And what is 2 1/4 cups minus 3/4 of a cup, folks? 9/4 minus 3/4 equals 6/4. 1.5 cups left. Okay? No, one last thing before you call it a day. If I use 1/3 of my sugar, how much of my sugar is left? 2/3, right? How do you figure out how much 2/3 of my sugar is? 2/3 times 2 1/4. How do we multiply fractions again? 2/3 times 9/4. 18/12. that's way easier. And again, it's using stuff that you know. This is what this is called, folks, is the complement concept. 1/3 and 2/3 are complementary fractions because they add up. All right. So, anyways, for next class, the idea now is that the homework, Chapter 2 evens. How many? Do you guys remember how many? Was it 2 to?
It was like 2 to 68
or something?
I don't remember.
2 to 68 evens.
2 to 62 evens and 64 extra credit.
Okay, 2 to 62 evens. Note, folks, the odd numbers, guess why I don't assign them? The answers are in the back. Please use that to your advantage if you think it might help. On Thursday, you get your 3 free ones from this chapter. Officially, it's not due until Tuesday of next week. That is the very last day that I will accept the homework. Please note that you should turn it in before that day, if at all possible, just so that you don't happen to be sick on that day. Then there's no excuse. Okay, folks? All right? And what I tell you is that if you are going to be sick on a day that homework is due, it is perfectly okay to email it to me. I'm all right with that. Okay? Or turn it in online as well, because you can just upload it into that homework, section as well.
I forgot. Do you say you want us to do the ones that are the lowest common denominator?
You can try to do the lowest common denominator ones, but the least common denominator questions, folks, there is one on the homework that I asked you to do. There's 2.
Yeah, 12 and 13.
When is it due?
Give them a shot. What I do is I always give credit to everybody for those 2 questions anyway. All right? And again, note, if you do not have your books yet, the homework is online. Just print it out from online inside the homework section, and then you can use that until your books are done.
And that's just the even questions in the homework that I printed out. I didn't even look at it. I just printed it out. So.
That reminds you, don't get to go home.
So, this class is on